Fun with magnets. Magnetic and non-magnetic materials. Magnetic materials are attracted to magnets while non-magnetic materials are not. Examples of magnetic materials include iron, cobalt, and nickel. Examples of non-magnetic materials include copper, aluminium, and plastic. Magnetic materials have magnetic domains, which are regions where the magnetic fields of individual atoms align. Non-magnetic materials do not have magnetic domains. Poles of magnet. Every magnet has two poles, North Pole and South Pole. The North Pole of a magnet is attracted to the South Pole of another magnet. Like poles repel each other. The strength of the magnetic force between two magnets depends on the distance between them. Magnetic fields are created by the motion of charged particles. Finding directions. Magnets can be used to find directions. A freely suspended magnet always aligns itself in the north-south direction. The Earth has a magnetic field that causes the north pole of a magnet to point towards the Earth's geographic north pole. Compasses are devices that use magnets to find directions. Compasses are used for navigation and orienteering. Make your own magnet. You can make your own magnet by rubbing a piece of iron, steel, or nickel with a strong magnet in one direction. This process is called magnetization. Magnetization aligns the magnetic domains in the material, making it a magnet. You can also make an electromagnet by wrapping a wire around a piece of iron and passing an electric current through the wire. Electromagnets are used in a variety of applications such as electric motors and MRI machines. Attraction and repulsion between magnets. When two magnets are brought close together, they can either attract or repel each other. The orientation of their poles determines whether they attract or repel. North pole of one magnet is attracted to the south pole of another magnet. North pole of one magnet is repelled by the north pole of another magnet. The strength of the attraction or repulsion depends on the strength of the magnets and the distance between them. Activity. Aim. To observe the behavior of a freely suspended bar magnet and other materials when rotated and allowed to come to rest, and to understand the concept of magnetic poles. Materials required: a bar magnet, thread, wooden stand, iron bar, plastic or wooden scale, 2 markers, compass. Procedure. Put a mark on one end of the bar magnet for identification. Tie a thread at the middle of the magnet and suspend it from the wooden stand so that it can rotate freely. Allow the magnet to come to rest and mark 2 points on the ground to show the position of its ends. Draw a line joining the 2 points. This line shows the direction in which the magnet was pointing in its position of rest. Gently push one end of the magnet in any direction and let it come to rest. Mark the position of the 2 ends of the magnet in its position of rest. Repeat the step 5 and 6 in different directions and note the final direction in which the magnet comes to rest. Repeat the step 2 and 7 with an iron bar and a plastic or wooden scale. Use the direction of the rising sun in the morning to find out the rough direction towards east where you are doing this experiment. If you stand facing east, to your left will be north. Using this, figure out which end of the magnet is pointing to the north and which points to the south. Observe that the end of the magnet that points towards the north is called its north-seeking end or the north pole of the magnet. The other end that points towards the south is called south-seeking end or the south pole of the magnet. Observe that all magnets have 2 poles, whatever their shape may be. Usually, north and south poles are marked on the magnets. Observation. A freely suspended bar magnet always comes to rest in the north-south direction. Other materials such as an iron bar and a plastic or a wooden scale do not show any particular direction when suspended and allowed to come to rest. Precautions. Avoid doing the experiment where there are currents of air. Do not use light objects for this activity. Use the direction of the rising sun in the morning to find out the rough direction towards east. Make sure that the magnet can rotate freely. Identify the north and south poles of the magnet before conducting the experiment.